Good everyone, welcome back. It is your favorite tutor on physics. Okay, today electrical work done in a circuit. All right, work done in moving a charge from one point to another in a circuit is given by the work done equals to the what? The charge times what? Potential what? Difference or the charge times what? The voltage. Now, this is the required equation for work done in a circuit. We all know that this equation is gotten from electromotive force, where we have the electromotive force is equals to what? Work done per unit what? Charge. So right here, we make work done subject formula, and then we have the what? The work done in moving a what? A charge from one point to another in a circuit. All right. Now, from this equation, we can derive other equation for work done in a circuit from this wonderful equation. All right, we know that this charge from, well, we know that, all right, from current, but current is what the rate of flow of what? Charge. So if we make charge subject formula, the charge is equals to what? The current times what? Time. And there we substitute what? The product of current and time in place of the word charge. So therefore we have another equation for what? Work done, ITV. Now this is another equation for what? Work done. Okay. So let's move further. All right. So you know that from Ohm's law, we know that V is equals to I R. That is why current times what? Resistance. So therefore, we substitute. We have what? Work done equals to what? I T, then what? I again, and arrow. Then the work done is going to be what? I raised to the power of 2, then T, then we have what? Arrow. So this is another equation for what? Work done in a circuit. Okay, let's go further. We know that from Ohm's law, this wonderful equation, if we make I subject formula, is going to be what? I equals to what? V over what? R. So therefore, work done is equals to what? V, we substitute for I, all over what? R. You know that I is raised to the power of 2, so therefore V over R is going to be what? Raised to the power of what? 2 times what? T, then times what? R. Then we have here R. Well, of course, this is the same as what? V raised to the power of 2 all over what? R raised to the power of 2. Then what? T. Then we have what? R. Now that this can cancel out. This one is raised to the power of 2. This one is raised to the power of 1. So to make this thing look beautiful, the work done will be equals to what? V square all over what? R times what? T. Now this is another equation for what? Work done. When we have this, we have this, we have this. Okay, consider we have a lot of beautiful equation for what? Work done. The thing is that the one to use depend on the kind of question you are given. Depend on the kind of question, that is the parameter that goes along with the question. So you will now decide on the one that suits the parameters in which you are given in the question. Okay, we know that we cannot talk about work done and leave power aside. Now let's talk about what? Electrical power. The electrical power in a circuit. Electrical Okay, we all know that power is the rate of doing work. So power is equals to what? Work done over what? Time. Or energy over what? Time. As the case may be. Work done over time or what? Energy over what? Time. Okay. Now, since all these are what? Work done. What we have to do, just divide this by what? Time. And then we have the equation for what? Power. So power, the first equation of power will be, now this is work done. Therefore, work done ITV divided by what? Time. Work done over time. Alright, the first work done ITV divided by what? Time. Time cancel time. The power is equals to what? IV. It's very, very simple. Power is equals to what? IV. Alright. These are equation for what? Power. Okay. The same thing here. The same thing we are going to do here. We just do what? Eliminate what? Time. So therefore power is equals to what? R raised to the power of 2 then arrow. Another equation for what? Power. Still the same thing. So power is also equals to eliminate time. We have V squared all over what? Arrow. This is another equation for what? Power. In a what? Circuit. So whenever you want to calculate for what? Power in a circuit, you bring the parameters out, you look for the one that suits the what? The question, and then you solve. Very, very simple. Okay, I have a question on the board. It's a very wonderful question. Yeah, we are going to solve it. It says, the headlamp of a car takes a current of 0.4 ampere from a 12 volts supply. Calculate the energy produced in 5 minutes. So we are looking for what? Energy produced in what? 5 minutes. So first thing we do, we bring the parameters out. Solution, we have what? Current. The current is equal to 0.4 ampere from what? 12 volt supply. V is what? 12 volts. The voltage is 12 volts. Okay. Calculate the energy produced in what? 5 minutes. So we are looking for what? Energy in what? 5 minutes. 5 minutes. Okay. Now these are the what? Parameters. And now that we have the parameters, our next step should make sure that these parameters are in their respective units. Okay, time should be in seconds, but is in what? Minutes. So we need to convert it to what? Seconds. 60 seconds make 1 minute. So therefore, this is equals to what? 5 times what? 60, which is what? 300 what? Seconds. And then we are looking for what? Energy produced in what? 5 minutes. We have I, we have V, we have what? T. We are looking for what? Energy produced. We have I, we have V, we have T. Now, energy, the same thing as the work done produced in the circuit. Okay, so which one I have? I, V, T. Okay, we use this one, the first equation. Because if you check, this equation suits this word question. We have I, we have V, we have T. We are looking for what? The energy produced. Same as the work done in the circuit. So we use this one. So therefore, the energy is equal to the what? Work done. And the work done is what? ITV. So therefore, the energy is equal to what is I? I is 0.4, 0.4 times what? Time. Time is what? 300 times what? V. V is what? 12. So therefore, E is equal to what? 144 what? Joules. Let me turn off the light. So this is our what? Energy produced in what? Joules. All right, ladies and gentlemen, we've come to the end of this episode. Please make sure you take this down, put it down, and don't forget about this equations. You have equations on work done in a circuit and equations on electrical power in a circuit. Subscribe to the channel. I remain your favorite tutor. Thank you, and God bless you.